Good afternoon, everyone. Welcome to the final session of the first day of our 2021 PyConZA. Lightning talks are what's up on the agenda today. We have 3 lightning talks this afternoon, or evening if you're in Durban and it's beginning to get dark. The first of our lightning talks will be presented by Nicholas de Kock. Then we've got a lightning talk from Adrianna Pińska and one from Simon Cross. The schedule for those lightning talks and what they're about and who's presenting them is on the website, like almost everything else for our conference is. Just for a brief reminder, if you've never come to a lightning talk session before, the idea behind a lightning talk is basically in the name. It's 5 minutes at most of something either interesting, something that wouldn't really fit in a big talk, and it's just something you'd like to tell us all. It is an excellent way, while I've got my soapbox, to get into conference speaking. If you've never done any conference speaking, if the thought of putting together a 30-minute talk is quite daunting, because what would you talk about for 30 minutes? 5-minute lightning talks are an excellent way to get started. And once you've done a lightning talk, you realize actually it's not that daunting, and a 30-minute talk is really perfectly reasonable. But enough waffling from me. Let's get ourselves going. Nicholas, are you ready to roll?
I think so. Can you see my screen?
I can't. Your sharing is not... It should be something I can turn on to share, but I'm not sure where that's gone. I think the sharing stopped. That looks likely. Right.
Sorted.
I'm going to reduce to this view just so that you can see me, so I'll let you know as we go along, as we're getting close to running out of time. Perfect. Thank you, Nicholas.
Cool. Good afternoon, everyone. It's my privilege this afternoon to present to you a brief overview of my honors project, which is the development of a Python library for automated exploratory spatial data analysis, or ESDA. So what is ESDA? It stems from regular exploratory data analysis, so gaining a brief understanding of any financial data or sales or orders or stock data. So it makes use of box plots, violin plots, histograms, you name it. And so the minute you add any spatial components, such as coordinates to that, it becomes spatial data, and it allows us to represent this data on a map. So that's where the spatial component comes in. We can derive various choropleth maps and map clustering of various phenomena. So what's the current problem with the ESDA process? Currently, it requires constant user input. So it needs someone running the code one row at a time. Usually, it's a repetitive process because the same thing needs to be done for various data sets. It's time consuming. The results are generated individually and can't be shared easily. So I don't know if this screenshot resonates with some people, but a whole bunch of windows and you know exactly what it means, but you can't kind of hand that over to someone else, a colleague or a client. And the same with the basic pandas summary in Python. You've got that in your code script, but it's not so easy to transfer and hand that knowledge over to someone who maybe doesn't have it. So there have been movements in automating exploratory data analysis. So that's without the spatial component. There's a SuiteViz library, which generates an HTML report, and a similar thing with the pandas profiling library. So the aim of my honors project was then to create one of these libraries with a spatial component. So that allows us to use a whole bunch of tools that can only be run on spatial data. So the aim or the endpoint is a short and sweet script. So you make sure that you input your data into a geodata frame, which is quite a popular way of working with spatial data in Python. And then you basically just run an autoESDA function, and the library should do the rest for you. So for this example, I'll be using the wards. It's a whole bunch of demographic data for the wards within the city of Johannesburg. So once this code is run, it will generate an HTML report. So the summary page gives you an overview of the study area and some overview and some statistics of the data set. There's also a sample, so that's the first and the last 10 rows. And then there's a page for each of the variables, so we can have a look at the Black African population. There's a box plot and a histogram and your Moran's eye statistics for the Black African population. We can see there's a hotspot for Africans towards the south of Johannesburg and a cold spot in the northern suburbs. And the opposite is true for the white population in Johannesburg. And then we can see our various choropleth maps here and how they differ according to the classification scheme that is used. And even though it's the same data, it just shows how you visualize it is what actually affects what the users see. So that's just running through the various income levels. And then there's a page here with the correlation between all your variables in the data set. So it's just the simple correlation coefficient in the matrix over there. But if that's not enough for you, you can go to the pair plot and actually see the scatter plot between your two variables that you're interested in. So just a reminder, that's all from one line of code, this autoESDA function, which is part of the library. So that saves the analyst a lot of time. It helps them work with large volumes of data, which are generated quickly and quite readily in this day and age. There's still a lot of work that can be done with this project. I'm still finalizing it and carving off the rough corners, but hopefully it becomes a valuable tool in the future that people in the industry can actually use. So that's a quick summary of my months of work, but if you have any comments or questions, you're welcome to get into contact with me or my supervisor. Thank you.
Perfect, thank you. We've got 30 seconds. We don't normally take talks on comments on a lightning talk, but this is a pertinent one. Ivan Blazek has asked, will this become available to the public at some point?
The plan is that it would become available, yes.
Perfect, thank you. Great, fantastic. Thank you, Nicholas. That was, yeah, okay. Well, actually, there's a follow-up question while I wait for it to show up. I'll display it here. Will you allow PRs to it in the future?
Haven't thought that far, but I'm always open to collaboration, so of course.
Perfect. Great. Thank you very much. Thanks, Nicholas.
Thank
I
you.
am reminded just before we move on to the next talk. Thanks, Nicholas. Appreciate that. I'm going to bring Adrianna on stream here so you can start getting your screen sharing going, Adrianna. Just to note, there is like with all the talks, there is a Lightning Talks Discord channel where some discussion will happen. It's where the questions are raised from and comments being made now about Nicholas's talk and presumably about the future talks as well as we go. Perfect. Adrianna, you ready?
Yes. Can you hear me?
I can hear you just fine. You might notice
Great.
on camera some slight difference since the last time you saw Adrianna chairing a session.
I have no idea what you're talking about.
Must be me. Cool. Right. Thanks, Adrianna. Let's go.
All right. So a few days ago, Python 3.10 was released. And the only reason that I know this is that a work colleague posted some weird looking syntax in our Slack. And I thought, what is this? Does Python have a switch statement now? So I went to look it up and discovered that this really cool new feature dropped. It's split across 3 PEPs. It used to be PEP 622, but it got bigger and bigger. And now it's 3 related PEPs, which you should read in reverse order. So PEP 634 is the formal specification, which is very boring and isn't really going to be very interesting if you read it first. PEP 635 explains why they did this thing. And PEP 636 is the really cool one, which is a tutorial explaining what the feature actually is and what cool things you can do with it. And there's a quick intro in Appendix A. So there's this new match keyword, and in its simplest form, it works a lot like a switch statement. You can match a variable against various constants and do various things. There's a magical wildcard, which is like the default in C++ or C. You can start doing some more clever things. You can use pipes to specify multiple options in a single case. And now it starts looking a lot more interesting than just a switch statement. You can unpack things into different possible things. So unpacking is a really cool feature, but we've always had this problem that if you want to unpack something but you don't know exactly what it is, it could be one of several different things and they have different structures. So you have to write all this boilerplate saying, okay, if it's this long and it's got these things in it, then you unpack it like this. Otherwise, you have to do this thing. Well, now you don't have to do that anymore. You have this nice compact and elegant syntax for matching possible different options. So in this example, if point is an XY tuple, it'll try and match these different things. It can either match to constant values inside the structure, or it can actually unpack things into variables. So for example, if this doesn't match, but this matches, it'll unpack the second value into Y, and then you can print it. And you can also do this constructor-like syntax for objects to unpack things into variables based on properties inside an object. You can nest these patterns as much as you want, so you can match things that are inside a list. You can also add additional guards to the cases to express additional conditions to match different things. And yes, if you want to know more, go and look at these 3 PEPs. They're very cool. They're pretty easy to understand. And Python 3.10 is very new, so you might not even have it installed yet. But here is a cool thing to look forward to once it is available in all the major distributions. And that is the end of my talk.
Thank you, Adrianna. That was excellent. 3 minutes that took you, out of interest. And now we all know something we didn't know 3 minutes ago. Well, most of us didn't know 3 minutes ago. I'm again going to accommodate a question because we've got the time for it. Adam asking, what do you think the advantages of this are over dictionaries as switch statements?
So dictionaries as in like using dictionary dispatch for like...
I would imagine, yeah.
I would imagine. I mean, this is more flexible. So this can do, I mean, if you want a switch statement, then we kind of had a solution for that already. But I think the coolest part about this is the non-switch statement-like applications, and specifically this unpacking, like unpacking into variable structures, because that was always like an annoying bit of boilerplate. And it's nice that there is now like this nice syntax that you can express this in a conceptually very simple way, and you don't have to repeat yourself by first checking some things about the structure and then doing the unpacking, when the unpacking should just magically handle all of that automatically, which it now does.
Cool. I'm just reminded while we've got a little bit of time in the lightning talk, just to point out there are other third-party versions of switch support that people have added to Python over the years as well. So there's a bunch of libraries you could install to do this. I think Michael Kennedy of the Talk Python podcast wrote something. He's the one I'm thinking of, but I'm sure there's others. And just not strictly related to what you're talking about, Adrianna, but while we've got a moment to point it out, it is something worth knowing for all of us Python users. The comment in the Discord channel to note that Python 3.10 shows much nicer error messages than it used to, which is actually
nice.
Certainly would have been a good lightning topic, and I've forgotten it. Just try it out next time you have, once you've installed Python 3.10, make some deliberate error, and instead of getting told syntax error, and you're supposed to know that means you try to divide by 0, you'll probably get told cannot divide this by 0. I think I've just come off the top of my head with a terrible example, because I think Python's always said you can't divide by 0. But there's lots of things the errors isn't as clear as it is now on 3.10, so that's worth exploring. Perfect. Thank you, Adrianna. And we're going to swap you out, bring Simon in. Right, Simon.
Hello. I thought that since Jade introduced her audience, I also have an audience. I have Purple Rat.
Excellent.
And Blue Pig.
Blue Pig, right.
And Bead Buffalo.
Of course, so quite a large audience.
Yeah, the house is packed. Yeah. I should share my screen.
Yeah, I was about to say, you're going to share a screen, Simon. We'll get that set up.
Yes. Nope. Is it this one? Nope. Maybe this one? Yes. Great. Can you see it?
Right. It's up. Good. Perfect. Simon, good to go.
Great. So taking the C API to the next level. Python is slow. Yes, I know that sometimes it's fast enough for you, and sometimes it can actually be pretty fast, but you don't have to trust me. There's this whole language called Julia. It's used by 10,000 companies. It's used by 1,500 universities. As of earlier this year, it has been downloaded 27 million times. And its motto might as well be, we love Python, but it's too slow, so we wrote Julia. There's these people who wrote PyPy. They've been working on it for 15 years. It's still going. It's actually got a lot of great functionality. It can be kind of 10 or even 20 times faster than CPython. And its motto is, we really love Python, but it's too slow. If you've worked in the scientific Python stack and you've tried to make things faster, you've probably encountered Cython, which is a way of writing C in Python. It's also been going a long time, massively popular. And its motto is that we love Python so much, we want to write C using Python because Python is too slow. Then there's another option, which was introduced by Armin Rigo and Maciej Fijołkowski some years ago. It's also extremely popular. It's a way of writing C in Python. It's called CFFI. It's kind of extremely well used. Many libraries have ported to it, even though it's kind of relatively new, I suppose, in this space. And its motto is kind of, I love Python, but I also know C. Python really is slow, not for all use cases, but for many. And you don't have to trust me or any reasons I'm going to give you, because there really are whole communities of people who've dedicated lifetimes of work towards solving the problem of kind of Python being slow. And so, I mean, Google have tried, Facebook have tried, Microsoft have tried to make Python faster. Kind of all of them have tried and failed and given up. And now even Guido is working on making Python faster. And so the question is, why do people keep failing? What is in the way? And one of the things that is in the way is the Python C API. So the C API is a way of writing C extensions to Python. And the C API has been really great for Python over the years. I mean, it's given us the whole scientific Python ecosystem. It's given us things like NumPy. It's allowed people to connect Python to high-speed messaging libraries like ZeroMQ. And lots of other great tools written in C. But it also has problems. And its problem is that really it's not an API. It just exposes everything. In particular, it exposes the memory layout of objects in C as they are in CPython. And it exposes kind of object lifetimes. So kind of basically, these are two huge chunks of how CPython works. And whenever someone wants to make Python faster, they encounter the problem that they have to keep the object memory layout the same and object lifetimes the same. And that makes it really hard to change everything. And it's not just for people writing alternative implementations. It's also holding CPython itself back from evolving. But we have a plan for solving this. And that plan is called HPy. The plan is pretty simple, and it's just don't expose the object memory layout and lifetimes. It really is a minimalist kind of plan, and I think that's why it can work. And it's not vaporware. It's a project which is kind of being written right now. It's been under very active development for the last year. It is an alternative C API for Python. It runs on top of CPython, PyPy, and GraalPython, and is already much faster on GraalPython and PyPy than the ordinary C API is, and it doesn't sacrifice any performance for CPython. And really, it's at the point where we need people like alpha adopters, people who are excited about playing around with early stage stuff, to come and join us and to help us flesh everything out and do a lot of exciting work. If you come and join us, there's a lot to offer. Like there are lots of things which having HPy might unlock eventually in the future, such as kind of having tracing garbage collectors or short-lived like nurseries for short-lived objects, or sub-interpreters for separate contexts, the ability to create specialized implementations of lists, and all sorts of other exciting things. And thank you very much. If you want to see a bigger version of this talk, it's available on the HPy project wiki as the C API Next Level Manifesto. Thank you.
Thank you, Simon. You're the only person in danger of me having to reach for a sock, but it was 5 minutes and 2 seconds, so nicely timed. We have got
Phew, just enough time to avoid the sock.
Basically, yeah. There's one question that came through, and because we have a little bit of time, we don't have as many lightning talks as we might have done. I am going to just post it. Question from Bruce Merry: does the CPython limited API help?
It's a good question. In a minimal sort of way, yes. I think the HPy doesn't need the limited API, and I think the problem is limited API doesn't really go far enough. It can't hide enough details. It does tend to kind of move towards. It does move the CPython API a little bit towards where HPy is headed, but probably not nearly enough to make a difference to alternative implementations. The one big benefit to the limited API is that if the limited API were to get general adoption, which is kind of not really the case now, it would allow HPy to target the limited API rather than the full C API, and that would give people benefits such as not having to kind of compile HPy modules for as many CPython, as many different CPython versions as they would if they were using the full API. So,
right.
So there's some advantages to using the limited API, but not enough.
In that case, I'll take the other question that we had, just because I'm aiming to wrap us up before 6, but we're not quite there yet. So one more question at the end of this lightning talk from Jonathan Carter: is HPython worth learning while learning compared to just using something like PyPy if you need some more performance? Simon, I'll leave that one, and then that any further questions and discussions, obviously, welcome to continue in the Lightning Channel Discord channel you just mentioned.
Yeah. So first I'll say I think HPy and CPy and something like alternative implementations like PyPy are sort of just completely different things. If you're just looking at pure performance, then PyPy. I mean, PyPy is one way to get performance. If you already have a C extension, I would say that kind of porting it to HPy is much more sensible than trying to kind of port it to PyPy. And unless you have some reason to believe for your particular problem that would be worthwhile. But largely for me, these are orthogonal questions, because HPython isn't a re-implementation of Python. It's just a new C API. So it can run on top of PyPy and on CPython and on GraalPython already. And the idea is that it will kind of run on top of any kind of Python implementation that adds support for it.
Cool. Great. Thank you, Simon. And thank you indeed to all our Lightning Talk presenters. Just going to find our trusty... Thank you to all of you. Those are 3 very different and very interesting Lightning Talks. As with all our talks, discussions still possible in the Discord channels. Discord won't close overnight, although most of us presumably are going to go at some point and come back tomorrow. On the topic of tomorrow, because nobody's heard me waffle enough today, Sheena and I will open again we'll present the opening talk tomorrow with a day that has even more talks in it than we managed to fit in today. So we're very much looking forward to another day of brilliant Python conference following what has, in my experience, been an excellent day today. That's it from us today. Thank you, everyone. We will see you all tomorrow. Have a good evening. Come back refreshed with some excellent new learning and talks to take in tomorrow. Thank you, everyone.